Dear colleagues, we should like to present you our research on the topic crop irrigation demand model and method within conditions of climate change in the Dnipro-Donbas Canal. Under the conditions of global warming and emergencies, humanity has to deal with negative development process of natural phenomena such as multiplication of the events and intensity of droughts, presence of a strong tendency towards increasing of the climate aridity and rising of the summer maximum temperatures are proved during the last decade. As a result, agricultural crops need more water during irrigation. Many different indexes were offered by researchers to characterize aridity and climate change. The soil moisture deficit index and evapotranspiration deficit index were proposed for agricultural monitoring. Today, there are many measures for minimizing of the negative impact of drought, but the most effective one is irrigation reclamation. Our research interests involve the criteria for water needs of agricultural crops using water balance models. These criteria include irrigation rates. It is necessary to develop methods for assessing of crop water demand changes under irrigation in a particular area of Ukraine. These areas are not sufficiently provided with water resources, and water supply is carried out using canals such as Dnipro-Donbas Canal, the object of our study. On the figure 1, there is a Dnipro-Donbas Canal system. Water is delivered from the Kamiensky Reservoir to the canal for different needs, such as water service for a population of Kharkiv city and Kharkiv district, the Siversky Donets River Basin environmental rehabilitation, as well as the water supply for irrigation systems. Remote water quality monitoring systems are already being developed. In a comprehensive study, it becomes necessary to develop methods for assessing changes in water demand for irrigation. However, the existing approaches to forecasting water the demand based on neural networks are not adapted to the conditions of agricultural irrigation. Therefore, a method in which stochastic curves of crop water supply are used as the basis for calculating the change in water demand is being developed. To analyze the dynamics of water demand, we use a water availability graph according to a water balance deficit of crops. So the crop water demand is reflected in the water balance deficit. The total deficit for the growing season is a biologically optimal irrigation rate. It is proposed a method which involves comparing these graphs for different periods as well as assessment of the total growing of water demand for different years. The data of the meteorological stations were used for calculating of water demand within Dnipro-Donbas Canal area. Average water balance deficit over 10-day period for major crops is calculated according to the data of meteorological stations within the canal area by the Formula 1. Evapotranspiration is calculated by the Stoichkos formula. We use Formula 1 when we have incomplete plane shading, and we use Formula 3 if we have complete plane shading. Where TCI is an average daily temperature, A is average daily value of relative air humidity. In a case of partial shading of the soil by plants, we recommend to use the formula 4, which is the linear dependence of expressions 2 and 3. The Stoichkos method allows calculating moisture evaporation by the field occupied by a certain crop for any period of time and water demand during the growing season. The advantage of this method is the possibility of using observational data on temperature and relative humidity over a long-term period from 1960 to 2015 at meteorological stations in the region of the Dnipro-Donbas Canal. Water use rate of agricultural crops, omega G, for a particular year, G is calculated based on the total deficit of water balance of crops during their growing season, taking into account the specificity of modern crop cultivation technologies. Formula 5. It was observed stochastic nature of variation of required cumulative water balance deficits, omega G for years, and probability of the year was calculated according to the total water balance deficit by the formula 6, where G is ranked number in the series and is number of years in a row. Using calculated probability of the year, formula 6, a graph of total water balance deficit rising was completed from the wettest year to the driest one. Feature 3. During study of changes in water use for irrigation due to climate change, entire series of observations was divided into 2 periods. And 1 is the number of years for the first period, and 2 equal n minus n1 is a number of years for the second period. Based on the data presented on the figure 4, there has been a rapid rise in temperatures on the Earth since the second half of the 1980s. While from the period from 1960 to 1985, there was no increase in temperature. This was used when selecting two time intervals of the same duration of 28 years each to compare the water demand of crops. Figure 4. A ranking of total water balance deficit for each period was done in ascending order for the certain plant. On the figure 5, we can see the graph which demonstrates water availability based on total water balance deficit for each period of the study. Figure 5. Rising trend of irrigation for different periods was evaluated according to areas S1 and S2, which bounded by integral lines of water availability based on total water balance deficit. Formulas 9 and formula 10. Growth of crop water demand under irrigation due to climate change is calculated using by the formula 11. It demonstrates the percentage change of water needs for crops in comparison with basic data of observations as 1. The relative change of crop water demand for each interval from n intervals is calculated by the formula 12. A moving average method is used for the forecasting this index. The forecast average value of water demand is calculated by that method as the average value of the total water balance deficits in the prior periods. To calculate crop water demand data of meteorological stations within Dnipro-Donbas Canal area were used. On the figure 6, we can see the location of meteorological stations within the Dnipro-Donbas Canal area. Assessing of crop water demand changes due to climate change. There are graphs of availability within a growing season for corn and alfalfa for the period from 1960 to 1987 and the second period 1988 to 2015. We can see that these graphs on the figure 7 for alfalfa and on the figure 8 for corn. Growing season of alfalfa has a long period and amounts seven months from March to September. Corn vegetates during summer from May to September, and irrigation season involves only 3 months from the middle of May to the middle of August. So increasing of crop water demand refer to different durations of the growing season of the plants. Graphics objective analysis shows growth of crop water demand for first period compare with the second one for the selected meteorological stations. Increasing is clearly demonstrated for dry and wet years. It was established that relative change of crop water demand during growing season is developing within Dnipro-Donbas Canal area. 13% for alfalfa and 22% for corn. To assess crop water demand trends, model use moving average method when time series of water needs were overlapped. The basic years for calculating of water demand S0 were period from 1960 to 1980 with duration of 21 years. On the figure 9, we can see a relative change of water demand for corn using moving average method when interval shift m equal 7 years at different meteorological station for period from 1960 to 2015. Analysis of the graphs shows that over the first two interval of time, trend of relative change of crop water demand when irrigation is decreasing for majority of meteorological stations, while for the last three intervals it is growing. The maximum of growth is observed within the last interval period from 1995 to 2015, and it is 33%. That means comparing with 1960 and 1980 period, the following two periods were wetter than one, and since 1981, drought phenomenon is increasing for the summer growing season of corn. Evaluation of crop water demand for irrigation in the presence of changing climate in the area of the canal will give the opportunity for agricultural producers to support favorable conditions for irrigated agriculture management, including the prospects of water providing for irrigation. To compare the water demand under conditions of stochastic natural moisture in the region, a method and mathematical models for assessing changes have been developed. The method consists in comparing the water demand of agricultural crops based on the calculation of water supply curves at different time intervals. Numerical calculations of 10-day moisture deficit and water demand norms are carried out on the basis of long-term observations at meteorological stations for temperature and air humidity deficit indicators. The mathematical model based on the use of the statistical moving average method is aimed at smoothing the long-term series of irrigation norms for agricultural crops by the criterion of the relative change in water demand in certain periods of time. This makes it possible to assess the trends of changes in water demand in the region over the past decades. Conducted systematic numerical calculations for the Dnipro-Donbas Canal region showed an increase in the criterion of water demand in the summer months, with irrigation for corn for grain up to 22%, for alfalfa up to 13% in the period from 1988 to 2015, compared to the period from 1960 to 1987. The trend of increasing aridity in recent years leads to an increase in irrigation rates. It is proposed to use the method and models in the systems of integrated water resources management in river basins in the zone of influence of canals to predict water demand for irrigation under conditions of climate change. For these purposes, forecasting of meteorological parameters is carried out and will be used in some regions of Ukraine, in particular in the Ingulets river basins. Thank you for your attention, and bye.